Mechanical Engineering AVIT. Hello everyone and welcome to today's session on Emerging Technologies for BS6 Engine, organized by Department of Mechanical Engineering of AVIT and Society of Automotive Engineers Student Chapter jointly. I would like to invite and request Dr. M. Prabhasa, Professor, Mechanical Engineering Department of AVIT, to deliver the welcome address. Please, sir.
Thank you, Akshay.
Okay, sir.
So, good afternoon, everybody. On behalf of the Department of Mechanical Engineering and SAE Professional Society, jointly organizing a webinar on the title of Emerging Technologies for BS6 Engines. I know Dr. Bhaskar sir very well. He's he has a very good expertise in the field of alternate fuels and engine emissions and performance area. And he has done a lot of research in this particular area, and he published several research articles and accolades like SCI Citation Index to Journal Papers and Scopus Index, Web of Science Index, and nearly around more than 1,000 publications he had done already in this particular field. And he is the right person for this webinar. I hope all the students, you will have a wonderful session in that next 1.5 hours time. I hope everybody is listen carefully this particular session, because this particular area is highly promoted research area, because alternate fuels and connecting with the emissions, it is a very important area in that field of people those who involved in the alternate fuel research. And you know very well, like a lot of research is going on in the present scenario in the field of alternate fuels. But one narrow area is that emission aspects. That emission is the important thing where we have to concentrate more on that particular, people, those who are involving in this research. Engine performance in one aspect, and another area we need to follow that emission norms. And recently, government has introduced Bharat Stage 6 emission norms, and all the engine manufacturers are requested to compulsorily abide that particular norms. And but to met out these particular norms, most of the engine manufacturers face some difficulties. And so now a lot of research is going on how to do some kind of strategies or can improve the engines so that we can able to abide under this BS6 norms. And still many people are confusing what is that BS6 norms talks about, and what mainly it is deals with all these things. So person like Bhaskar sir is he is having a very good expertise in this field. He is the very apt person to talk about this particular session. That's what I am telling already. The next 1 hour period, you will get a wonderful session regarding this. I hope it should be an interactive session. And students, please have if you have any doubt, you have to keep it in your mind. And at the end of the session, you can ask. And I thank Bhaskar sir for this wonderful webinar, and as a speaker for this session. I thank you once again, and I hope the session can start now. I request Tyagarajan to proceed further.
Thank you, sir. Welcome for those of you joining now. Now we would like to invite and request C. Tyagarajan sir, Associate Professor, Mechanical Engineering Department, AVIT, to address and give an introduction about the speaker of today's session. Please, sir.
Are you audible? Audible?
Yes, sir.
Hello? Okay. Good afternoon, one and all present here. So first of all, I thank Dr. Bhaskar sir accepting our invitation as a resource person of the today program. Thank you, sir.
Thank you.
Next, I thank Dr. Prabhakar sir and Lakshman sir for helping me to arrange a guest for today's program. Thank you, sir. So next I can move on the introduction guest part. So Mr. Dr. Bhaskar sir, now the professor and head in Department of Automobile Engineering in Rajarashmi Engineering College, Chennai. He has 22 years of experience in teaching and research and 1 year of experience in industry. He obtained his undergraduate degree from the Madras University in 1997. He also received MS by research in the field of internal combustion engines from the Anna University in 2002. And he also obtained PhD in Anna University in 2004 in the area of HCCI engine with alternate fuels. He has published 100 research papers, including 46 Scopus Index and 10 international journal publications with high impact factors. He is a reviewer for many peer-reviewed international journals. His biography is included in the Marcus Who's Who in the World 2015 and 2016 based on his research publications. He is also co-authored the title of Engineering Mechanics and Engineering Drawing to his credit. He has delivered many special lectures and practical training sessions to the employees of automotive industries. He is also active member of Society of Automotive Engineers like SAE. His research area of interest includes engine combustion, alternate fuels, and emission control. So, thank you. So, I hand it over to Mr. Akshay Surendra.
Thank you, sir. Thank you, sir. Next, I would like to invite our honorable guest, Dr. K. Bhaskar, sir, Professor and Head of Department of Automobile Engineering, Rajalakshmi Engineering College, Chennai, to present the session. Please, sir.
I thank Tyagarajan sir for his wonderful introduction and Prabhakar sir also for the wonderful introduction. I know Prabhakar sir very much and all the whole Lakshminarayan sir was an old friend of me and he asked me to give a lecture. Right, based on that in talk only now this lecture is planned. I thank everyone who gave the opportunity to talk to the students. Now I will officially present the thing. The screen is visible?
Yes, sir, visible, sir.
Yes, sir, yes, sir, visible, sir.
Visible, sir. Yes, sir, visible.
Dear students, good afternoon.
Good
We
afternoon,
are going to discuss about emerging technologies for BS6 engines. I hope in your curriculum you might have read internal combustion engines. If any point what I am discussing is not convincing, if you want further explanation, please ask me, right, then and there, right, so that we can go in a smooth manner. Right, I would always like to have a interactive session with the students.
Okay, sir.
Right. Can we do like that?
Yeah, sure, sir.
Yeah. Oh, the next screen. Okay. Anybody likes this scenario? Definitely no one will like, right? We need automobile, right? But we don't want pollution. There is a drastic development in the automobile sector, right, to handle this pollution, right? It is not that only automobile alone is giving a pollution. There are a lot of industries also contributing, and transport sector and the places where the combustion takes place are the main sources of carbon monoxide and oxides of nitrogen, right? So we don't want this. So we are going to discuss about how we can able to tackle this. Before going into that, we must know emission. What is this emission? Anything which is not good for the human being or atmosphere or plants or animals, right? That we call it as pollution. And whatever pollutant which is coming out of the engine, we call it as emission, right? In SI engine, normally we have three major pollutants: hydrocarbon, carbon monoxide, and oxides of nitrogen. Please remember these three things: hydrocarbon, carbon monoxide, and oxides of nitrogen. Normally it is denoted as NOx. That means it consists of several oxides of nitrogen put together called NOx. Then your diesel engine, compression ignition engine. Compression ignition engine, we have one more pollutant extra, right? CO is there, carbon monoxide is there, hydrocarbon is there, oxides of nitrogen is there, plus we call it as particulate matter, right? Particulate matter is normally called, is a solid form of soot. We can easily see black smoke coming out of the engine, right? When you see a public transport flooded with people, normally in the exhaust you will find black smoke in the exhaust, right? So why it is coming, we'll discuss it. Before going to that, okay, these pollutants, what will be the problem? Say carbon monoxide. Carbon monoxide is the one culprit, right? So we need oxygen, right? When we inhale oxygen, the hemoglobin in the blood will be attracted towards it, and it takes the energy throughout the body. That is the purpose of inhaling oxygen. When you inhale carbon monoxide instead of oxygen or in a combination, right? This hemoglobin in the blood is 200 times affinity towards the CO than oxygen. So 200 times it is having a higher affinity. That means what? Instead of forming a oxygen combining with the hemoglobin, carbon monoxide will combine with hemoglobin in form of carboxy hemoglobin, right? It is all depends on how much you inhale, how much duration you are exposed to, right? When you are inhaling a very small value and a very short duration, then you will find a headache, right? When you are having a large duration and with a large amount of carbon monoxide, it can go up to death, right? So it will start from a small headache to a death. To some extent, this carbon monoxide is possible, right? Please understand the significance of it. Hydrocarbon. Hydrocarbon, your fuel itself hydrocarbon. Your petrol or diesel is a combination of different hydrocarbons, right? When the fuel is supplied to the engine, it is not completely combusted at all times. It may be partially combusted, or sometimes it is not participating in the combustion, it goes in the exhaust, right? So unburned fuel or partially burned fuel, both are going out of the engine, right? When it goes out, is all the hydrocarbons are really possible for humans to have a problem? No. We say reactivity index. We say reactivity index. When the hydrocarbon is emitted to the atmosphere in the presence of sunlight, right? Whether it can able to readily react with the other components which are available in the atmosphere, right? When it is readily reacting, then reactivity of that particular hydrocarbon will be more. When it is not reacting, it is called again the methane. Methane is one of the best example which will not contribute. We will not call it as emission, right? Even though hydrocarbon emission, methane is also hydrocarbon, it will not react with any other component in the sunlight, right? So emission regulations itself they will say NMHC, non-methane hydrocarbon. Total amount of hydrocarbon will be split into non-methane hydrocarbon and remaining hydrocarbon. Okay. But this hydrocarbon can contain aldehydes, formaldehyde, acetaldehyde, right? All these things can form a irritation to eye, throat, a possibility of cancer. Formaldehyde, acetaldehyde is responsible for the cancer, but those things are very, very small values, right? Then oxides of nitrogen. Oxides of nitrogen, again, it will be formed only when the high temperature is reaching and availability of oxygen. Both the cases, both are there, then definitely you will find oxides of nitrogen formation in the engine combustion. When you inhale nitrous oxide or nitrogen dioxide, then you will find cough in chest discomfort, eye irritation, right? When you are inhaling for a longer duration of time, when you are very close to the signal, your office is located very close to the signal and you are continuously inhaling the oxides of nitrogen, then you will find cell structure itself will be having a problem, right? So please understand that. And then suspended particulate matter. The suspended particulate matter, right? Normally, when the fuel is forced to burn, right? When the fuel is normally burning means the fuel is hydrocarbon and you are supplying oxygen. Oxygen and hydrocarbon combines, right, homogeneously, and complete combustion takes place. Then you will find only carbon dioxide and water vapor. Both are not emission with respect to IC engine people. But this is not happening at all point of time, right? Especially in diesel engine, right? Heterogeneity is always there, right? The air is sucked inside the combustion chamber, right? And fuel is sprayed. Fuel is sprayed inside the combustion chamber, right? So there will be a fuel-rich regions, there will be air-rich region, right? When the fuel-rich region is forced to burn, you will find without oxygen, the fuel will be decomposed. That is what we call it as soot, carbonaceous material, right? This carbonaceous material will combine together. It forms a particulate matter. It can coat on the other SOC organic matters, right? It can come out as a particulate matter, right? This particulate matter, the size, each and every particulate matter will have a different chemical and physical problems, right? Physically, dimensions are very, very important. How much size it comes out, and what is the nature of that chemical. All those things put together, it will form a respiratory problems, chronic bronchitis, right? The early stage of cancer, lung tissues will be affected, right? If you inhale more, you'll find cancer. Right, as I said, particulate matter is a very, very dangerous component depending upon the size. When I say PM10, PM10 will be filtered in the nozzle upper trap itself, right? PM 2.5, when the size reduces to 1/4 of it, then it can go to lower respiratory tract. Then PM1, then it will go to alveoles, right? That is the lowest, smallest component which is available in our lungs, right? To that extent, it will go, right? So when it goes very close to the smallest component, then you will have a large amount of particulate matter of PM1 size. Then you will find part of the lungs will not be in active mode, right? So your respiratory system will not be functional to the expected level. Furthermore, PM 0.1 will create a lot of problems which can go through the blood, and it can go to any part of the body. To understand its effect, this is your human hair, right? Human hair has 50 micrometers, right? Particulate matter of 2.5. You please understand the size of human hair and particulate matter. So very, very small, right? So when it goes into the body, then it will have a lot of issues. Right, normally who will be more affected? The traffic constables. Traffic constable who are present in the traffic junctions, right? Heavy traffic junctions, right? Normally the people will be in the rotational basis, right? Traffic constables, because they are the worst people who are affected by means of particulate matter, right? On a whole, what happens throughout the world, right? The emission is first popped up in the concept of emission control. Everything comes out in the 1952. 1965, USA, they came out with the standards. Later, it started its journey to a greater extent. In India, it is around 2000, right? India 2000, which is the year which we implemented BS1, which is very close to Euro 1. And you must know why we call it as Euro 1. In the world, there are three major countries, they formulate emissions. All other countries will follow it, right? One country is Europe, the other country is US, then one more country is Japan, right? and we are following European standards, right? And we'll slightly modify it, and we'll try to follow the Euro norms based on our conditions, right? Please understand, step by step only we have applied the emission norms. For example, Euro 2. In 2001, it is introduced, but it is in Delhi, Mumbai, Kolkata, and Chennai. Only in the 4 major metropolitan cities, right? Later, 13 cities were identified, plus these 13 cities are available here. Then only it will be, see, 2005, Euro 3 is at 2005, 13 cities plus Delhi, they implemented Euro 3. The remaining part of the India will use Euro 2, right? In 2010 only, Euro 3 is nationwide. Is it clear? Right? So please understand, only when we implement a new emission standards, only in the selected cities, metropolitan cities, we'll try to implement, and we'll see the success. Then after seeing the success, then they will implement all over the country. Right? Now, you look at 2020 March, always you'll find always April 1st will be, the norms will be implemented, right? That is the tradition we follow, right? In any year which is implemented, it is from the April 1st, right? 2020 April 1, we must have got Euro 6 norms, but due to this COVID situation, we are not able to implement, a little delay in that process. And one information you should know is Euro 5 we have skipped. Euro 5 we have skipped, right? Euro 4 is introduced in 2010. 2015 we must be in a position to introduce a Euro 5, but government and the manufacturer, they decided, work together and formed a committee, and they decided to implement 2020 nationwide, not in the selected cities, nationwide. From 2020 onwards, Bharat Stage 6 norms will be implemented. So what is this norms? Right? If you look at it, there's no big change in BS4 and BS6 with respect to CO and HC. But NOx, it is reduced. There is a new term which is coming up in the petrol engines, particulate matter and particulate number. So please understand, there is a new terminology which is entering into the emission norms from BS6 onwards, right? Particulate matter for petrol vehicle. Earlier, particulate matter is implemented only for diesel vehicle, right? Till BS4, we don't have particulate matter, right? Now only we have introduced the particulate matter, right? And particulate number, which size of the, see, we should not go beyond this, right? That is also another, the size as well as the quantity. Both are introduced because for achieving Euro 6, one technology in petrol engine, right? GDI, right? What is GDI? Anybody? What is GDI?
Gasoline direct injection, sir.
Yeah, gasoline direct injection. What do you mean by direct injection? We are injecting directly the petrol into the combustion chamber. Prior to GDI, we use MPFI and carburetor, throttle body, all those things, carburetor, throttle body injection, MPFI system, all these systems will prepare a homogeneous air fuel mixture outside the engine, and it will supply as a homogeneous air fuel mixture to the engine, right? In GDI, just like a diesel engine, we are injecting the fuel, right? So when you inject, always you will find little bit of heterogeneity. When heterogeneity comes into picture, you will find definitely a particulate matter, right? So please carefully look at it. There is a suffix, superfix B, right? That means only for DI engine, direct injection engine. That means what? GDI. Right? In petrol cars, for a normal MPFI system, we have only same emission norms, CO, HC and NOx. Right? Particulate matter will not be there, and particulate number is also not there for MPFI systems. Right? If you are able to meet the emission norms by means of MPFI system, you need not worry about particulate matter and particulate number. I'll ask you a simple question. Why? Because have you ever find a black smoke in the petrol vehicle? Or which vehicle will have a black smoke?
Diesel engine, sir. Diesel.
Have you ever seen a black smoke in the petrol engine?
No, sir.
Why?
Why? I don't know, sir.
The reason is we always operate petrol engine very close to stoichiometric air fuel ratio, very close to stoichiometric chemically correct mixture or stoichiometric air fuel ratio. We don't go very low air fuel ratio or very high air fuel ratio. Okay. Right? But in diesel engine, always you will have indirect injection engine. So, see, direct injection or indirect injection, both the cases you will find heterogeneity. Right? You will have a very low air fuel ratio to very high air fuel ratio is possible.
Okay. Thank you.
Clear?
Yes, sir.
So, petrol engine la the problem kadayadu. We don't have fuel rich zones.
Sir. Sir, the petrol quality adhigam varukkanadala andha mari virudha, sir?
No. It is the air fuel ratio. Right? Okay. What is the quantity of oxygen which is required for complete conversion of all the carbon to carbon dioxide, all the hydrogen to water vapor.
Sure.
Right?
Right.
That is the quantity of oxygen required. For that oxygen, what is the quantity of air required? That air is homogeneously mixed. Say, for example, that value is 14.7:1 for petrol. Right? We normally operate 10% this side, 10% that side. Okay, in MPFI system. Is that clear?
Yes, sir.
So we don't go to 9:1 or 19:1. We don't go for that. Right? So we don't find any fuel-rich packets inside the combustion chamber. That is the reason why we don't find any black smoke in the exhaust. Okay?
Okay.
In the petrol engine. Right? Emission norms for diesel vehicle. Right? Diesel vehicle, there is a great change. CO is same value we are following, and hydrocarbon and NOx combinedly it can be allowed to 0.17 grams per kilometer, and NOx will be 0.08. That is a drastic reduction. If you look at it, there is a drastic reduction of NOx from 0.25 to 0.08, and also particulate matter 0.025 to 0.0045. There is a great reduction of NOx as well as particulate matter. Right? So please understand, so technology must be implemented in such a way that we should be in a position to meet all the emission norms. Then only the cars can be sold in the market. Just a glimpse about Euro norms and Indian norms. Euro norms started in the year 1992 and Euro 6 was implemented in 2015. But in India, 8 years later only, Euro 1. India 2000 is implemented, and 2020, right? So started with 8 years lag, and we are having a lag of 5 years now, right? BS6 is going to be implemented in 2020, right? To look at the values, right? How stringent our emission norms. Sometimes numbers will not give a real meaning, right? When you see it as a diagram, right? You look at the Euro 3 standard. This much amount of rectangle area is available to work with. That is particulate matter and oxides of nitrogen, NOx and particulate matter, right? For a diesel engine, right? Euro 3 is this. Almost 25% only Euro 4. From that it is 50%. Now it is very, very less. When compared to this, is nothing, right? Sometimes they may say 0, 0. The day may come. I don't know. This is again where we stand. That also you can look at from this. BS6 and Euro 6 are almost same, right? There is no big variation, right? All the values are same. That is to ensure we are meeting the Euro 6 standards. Okay. Have you looked at the units? What is the unit given here? Can anybody read? Gram per kilometer. When I say CO, HC, NOx, particulate matter, everything is so many grams per kilometer. When the vehicle is running per kilometer, how much amount of gas, how much grams of this particular emission is emitted to the atmosphere? That is what it means, right? How it is tested? Have you tested your vehicle in the emission? Have you taken an emission control certificate? Anybody? Two-wheeler or four-wheeler?
Sir, emission control certificate means, sir, license irukku, emission control
Just like license, you must have a emission certificate also with your vehicle. Every 6 months you have to update it. In the petrol bunks, normally you will find, right? In the petrol bunks also you can measure, and that will be a idling emissions. That is no way connected to this. Please understand, that is no way connected to this.
Okay.
Right? That is what I am trying to say.
Okay.
What it means is, as I said, we are taking every detail from the European countries, right?
Okay.
So European countries, they will have their own roads, right? See, if you look at an highway, how many vehicles are flying on the highway? What type of vehicles are flying? How many two-wheelers? How many four-wheelers? What signals you have? What is the driving pattern of the drivers? What is the maximum speed that is achieved in the road, right? So you may have a vehicle which will go up to 200 kilometers per hour, but are you riding it in the Indian roads, right? That will be different, right? So statistical data will be taken, right? How the driver drives a vehicle on the road, right? There are a lot of statistical data will be taken into account. How much, say when you take your vehicle from the home to the office, right? You will start with idle, then you will accelerate, then you will have signals idle, then you will accelerate, maintain the same speed, then decelerate, right? All these acceleration, deceleration, hot idling, cold idling, all those things will be taken into account, and all these information will be put into the software, and this software will give you a driving pattern, right? Driving pattern of a driver, right? Particular vehicle, right? So that is the driving pattern. This is what we call it as driving cycle. In the x-axis, we'll have a speed. In the x-axis, we'll have a time, and y-axis, we'll have a speed. Speed versus time. Is that clear? What is this driving cycle represent? The real driving pattern which is happening in the roads, right? That is the average value. How much amount of acceleration, how much amount of hot lighting, how much amount of deceleration, all those things will be taken into account. And this blue line is the representation of a real-time driving to a laboratory driving. Is that clear? Are you able to understand what it is?
Yes, sir.
Now, at all points, right? Say, for example, 13 modes driving cycle. In this driving cycle, we'll take at a different points, we'll take the emission sample, right? Say, for example, this is the emission sample. The vehicle will be running at that condition, but major portion will be taken here and minor portion will be taken here, right? All those things with the additional factors, right? Exhaust sampling will be taken only at a particular points, not continuously. So please understand that. So clear? But here the vehicle will run continuously, but samples will be taken only at a different points. How the vehicle will be running? Normally, road will be fixed. Vehicle will be running on the road, right? Here in the testing center, the vehicle will experience whatever it is experiencing on the road. That means what? When it goes with a very high velocity, then the wind resistance will come. The same wind resistance will be offered by a vehicle cooling fan, right? The road will be represented as a drums, right? These wheels represents the road. Here the vehicle will be fixed and the road will be moving. Are you able to understand?
Sir.
Yes, sir.
Right. Now, as usual, how you run on the road, same way the driver will be inside, sitting inside the vehicle and he will drive the road. You are playing a lot of video games, right? There will be a track will be given, right? In the F1 race game, right? Lot of vehicle racing games, right? The same way, this pattern will be your driving cycle, right? The driver will carefully drive according to the driving cycle, right? And tailpipe will be connected to the emission analyzers and samples will be taken continuously. Are you able to understand? So when I say grams per kilometer, that means it is tested, not tested on the road, it is tested in the laboratory conditions. Tested in the laboratory conditions. Is that clear? Is that clear?
Sir.
Yeah. Any questions you want to ask? Okay. Now, can we move to the next step?
Yes, sir.
Okay. Now, I'm going to concentrate only on CA engine. This is SI engine. That does not waste much of a time. But one thing you should be in a position to understand between SI engine and CA engine, NOx formation. Right? NOx is what? Oxides of nitrogen. Right? It is called oxides of nitrogen. When I say oxides of nitrogen, in general, there are seven different types of oxides of nitrogen are combinedly called NOx in the air pollution segment. But in vehicular segment, it is only two oxides of nitrogen. One is NO, other one is NO2. Nitrous oxide and nitrogen dioxide. Right? These two are considered as a pollutants from engines. If you look at the SI engine, scenario, 98% of NOx is NO only. When I say NOx in SI engine, it is only NO. Right? When I say NOx in SI engine, it is only NO. Only 2%, that too at a maximum condition, NO2 will be 2%. Is that clear? Is that clear?
Yes, sir.
But in CA engine, scenario is completely different. Completely different. Right? You will find up to 30% of NO2 is possible. Up to 30% of NO2 is possible. That means what? Total oxides of nitrogen, 30% share will be NO2 and remaining will be NO. That is possible. Right? When you go higher and higher speed, the NO2 percentage will drastically come down. It can be up to 10%. 10% NO2 and 90% will be NO. So the percentage share of NO2 will be different for CA engine and SI engine. Okay. And how these oxides of nitrogen will be formed? Please remember this three things very carefully when the NOx will be formed. One is high temperature. That means more than 1700 degrees centigrade, right? Inside the combustion chamber, whenever there is a 1700 degrees Celsius, above 700 degrees Celsius, 1700 degrees Celsius, right? Your nitrogen available in the normal atmospheric air, 79% is what? Nitrogen, right? This nitrogen will be inert gas, which will not participate in the combustion. But when the temperature is exceeding 1700 degrees centigrade, then this nitrogen will come out, right? That will be split into N plus N, right? And oxygen will be split into O plus O, nascent oxygen. If you look at it, O and N2 will combine, it will form NO plus N, right? Nitrous oxide plus N. And then again this N will combine with O2 equal to NO plus O. So again O will be available, right? So this is called chain reaction, Zeldovich chain reaction mechanism. If the three things should be there. One is high temperature. The second one is availability of oxygen. Third is a minimum, very small effect, that is time. You must provide enough time for these reactions to happen, right? So high temperature and availability of oxygen is the main criteria for NOx emission. Is that clear?
Yes, sir.
Okay. Now, NOx can be controlled by EGR. I will come to this graph little later. CO. See, CO fundamentally, right? What is the air fuel ratio I said for petrol engine? What is the air fuel ratio I said for petrol engine? Stoichiometric air fuel ratio. Just now I said, right?
14.7:1.
Very good. 14.7:1. How the engine operates? Very close to that, right? Very close to that air fuel ratio. Okay. CO emission. See, in diesel engine, what will be the air fuel ratio? Anybody can guess? What is the overall air fuel ratio? Anybody can guess? Stoichiometric air fuel ratio of diesel is 15:1.
14.5:1.
No, that is 15:1, right? Approximately 15:1. But the operating air fuel ratio for a diesel engine for no load condition, no load and low speed conditions, you will find even 100:1 to 80:1, 80 to 100:1. That means what? 100 parts of air and 1 part of fuel. In full load condition also, it will have a 20:1, right? Overall air, overall fuel that comes into the system, right? At high load conditions, it is 20:1. At low load condition, it is, what is the value? 100:1. So clear? We are not controlling the air. Air is almost fixed in diesel engine. Only the fuel quantity supplied is varied. Is that clear? So, whenever we operate at a lean operating conditions, that means more amount of air is supplied for the given fuel, then you will find a very less amount of CO. So CO is not an important factor in the case of a diesel engine, but in petrol engine, it is very important because we are supplying a very close to stoichiometric air fuel ratio. If at all that is a mismatch, then definitely you will find hydrocarbon in the exhaust. Is that clear? Is that clear? The CO emission with respect to SI and CI engine. These are all very interesting points, but I don't want to discuss now. Okay. So look at, this is the injector. Now you are now inside the combustion chamber, right? And you are looking at the injector. In diesel engine, we have injector, right? Do you have any doubts in that? Fuel injector in the cylinder head, right? Yes or no? Diesel
No,
is
sir, no,
sprayed
sir.
through the
No, sir.
fuel injector. Yes. You are right, right?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now you look at the injector. This is the fuel which comes out. Right? The fuel is emerging out of the injector. What is the pressure of the fuel coming out of the injector? Normally, okay, minimum. See, atmospheric pressure is 1 bar. Please understand, atmospheric pressure is 1 bar. Right? The fuel which comes out of the injector is 200 bar. Minimum 200 bar. For a mechanical injections, we can go up to 1000 bar. What is the range I said for mechanical injection? What is the range? Can you spell out? 200 bar to
1000 bar.
1000 bar. Okay, that means what? 1000 times higher than the atmospheric pressure. Okay, right? Now, this is coming out of the injector, right? So when it comes out, what is this? You will have only fuel, right? Here, what you will have? Only air. So there will be heterogeneity. That is what we call as heterogeneity. So these are all the places where you will find air fuel ratio which is very close to stoichiometric air fuel ratio. So please understand this one fundamental thing. When the fuel will burn, any fuel for that, any liquid fuel that matters, right? Say for example, you want to burn the wood, right? You want to burn the wood, what you will do?
We'll fire.
See, I want to burn the wood, right? Say how you can use a liquid fuel for that quickly. Burn. What fuel you want?
So anything like petrol, diesel, anything.
Petrol or diesel?
Sir, diesel.
Petrol or kerosene normally preferred. Okay,
Kerosene.
kerosene is preferred.
Kerosene,
Right?
kerosene, sir.
Okay, I'll pour kerosene. What you will do? Will it fire?
No, we need
Yes.
to fire it.
You need to
We need to fire
Ignite
it.
it
how?
By
by making in contact with the fire.
Fire means
A flame.
matchstick.
like a matchstick lighter or anything. Sir.
Okay. Please understand sequence of operation for that particular operation. I am pouring kerosene, right, into the wood. Then what will happen? Kerosene will become vapor, right? Or petrol will become, when the petrol will become vapor, do you know what minimum temperature at which the petrol can produce its own vapors? What is the minimum temperature? Even at minus 40, 47 degrees centigrade, the petrol can produce enough vapors for burning. What is the temperature? Minus 47.
Minus 47.
What is your atmospheric temperature? Plus 30. So if you take plus 30 and 40, almost 70-degree difference is there. So this 70-degree difference, heat is available in the air. So this air will supply heat and the fuel that is poured onto the wood will evaporate. Not only evaporate, it also mixes with the surrounding air, right? Not only mixing with the surrounding air, it forms very close to stoichiometric air fuel ratio. Will it burn? No, it will not burn. When it will burn? Only when this mixture, homogeneous stoichiometric air fuel ratio, lifted, right, raised up to self-ignition temperature of the fuel. Say self-ignition temperature will be around 250 to 350 degrees centigrade for a particular fuels, right, depending upon the composition. Right, your atmosphere temperature is only 30 degree. It is not sufficient to heat up to 230 degree or to 300 degree. Is it right?
Yes, sir.
Yes, sir. Yes or no?
Yes, sir.
That is the reason why you want a matchstick. Right? That is the reason we want to matchstick, right? Matchstick, what is the temperature of the matchstick? What is the temperature of the matchstick? It will be around 700 to 900 degrees centigrade. Right? So when I put it comfortably, it will heat up to 250, 300 degrees centigrade, then it will burn. Is it clear?
Yes, sir.
Are able to understand the sequence of operation in that? The same thing you
Yes,
put
sir.
it here. Right? Now I am, what is this engine called?
Emission in IC.
What is this engine called?
Compression ignition engine.
Yeah, compression ignition engine. Right? What is the ignition source here?
Spark plug. No, sir.
Now,
Compression.
okay.
Compression.
What is the CA? What is the CA?
Compression ignition.
Yeah, compression is the ignition source. So please understand, I am compressing it, right, well above the self-ignition temperature of the fuel. I need to increase the temperature of the air well above the self-ignition temperature of the fuel used. So that is the reason why I am heating up to 700 degrees centigrade. If you want 700 degrees centigrade, you want to go for a high compression ratio. That is why your CI engine will have a higher compression ratios when compared to SI engines. SI engine, we use a spark. Spark will do that purpose. Spark will heat, right? It will rise above the self-ignition temperature. Here, only the compression is the source. That clear? So surrounding air will have a 700, 800 degrees centigrade. Through that, the fuel sprayed. So somewhere where you will have homogeneous air fuel mixture, right? This homogeneous air fuel mixture again takes the heat from the surrounding air. It will rise up to the self-ignition temperature and it will burn. When it burns here, it will have a flame, right? When it burns, over a particular point, the flame starts, right? It will try to propagate in all directions. The flame is having a natural tendency to propagate in all directions. Is I right or wrong? Are you able to see the stars here?
Yes, sir.
Right, these stars are very near to the stoichiometric air fuel ratios. Right, this is the place where the combustion starts. That means the flame starts. This flame will try to propagate in this direction as well as this direction. So when it try to go towards this direction, you will have only very less amount of fuel. So combustion will start, intermediately it will stop. So intermediate means unburned or partially burned hydrocarbons will be formed. When it goes towards this direction, you will have only a rich fuel or only fuel. But this flame is having 2500 degrees centigrade. So it will try to decompose the fuel. That is why soot is formed. That is why soot is formed. Are you able to understand this?
Yes, sir.
Yes, sir.
Okay. So now, are you able to understand what is soot? This soot will try to combine and it will form a bigger size as it progresses. Right? That is what we call it as particulate matter. What we see as a smoke is, so it's a soot. The black color, see, you assume a small pipe, a transparent glass pipe through which air is moving. Can you see the air? Is it possible to see air in a glass without any contamination? The air is available. Can you able to see? Normally no, right? When I throw a black powder, small amount of black powder into the air, then can you see the air motion through glass tube? பார்க்க முடியுமா?
ஆமா சார் பார்க்க முடியும்.
Right? That is what a small gray. When I pour more amount of black powder, then what will happen?
It will be spread, sir.
It will become black. That is what happening when you overload a diesel engine. When you overload a diesel engine, most of the places you will find fuel rich zones, and wherever the combustion is possible, all the flames will try to decompose the fuel. It will form large amount of soot, and this large amount of soot goes into the exhaust, and it will form a suspended things, right? So you will find a black smoke in the exhaust. Is that clear?
Yes, sir.
This is how the soot is formed, right? I am not going into the depth. Okay, now we'll come to the control strategies. Now we know what is emission standards, what is emission out of engines we discussed. Then what we discussed, what is BS6 norms, right? Then how it is measured, then how the pollutants are formed. So far we have discussed about these things. Now we will discuss about how we can able to control these emissions, right? There are only two things, two important things we can able to control: in cylinder control or after treatment devices, right? There are two things. Now directly we'll go into the BS6 norms. How much time is available till now? Now we have
Now 3:30.
okay 3:30. Still I have another 30-40 minutes.
Yes,
Yes,
sir.
sir.
Okay, sir. Okay, sir. We'll continue, sir.
Can I proceed?
Yes, sir. Yes, sir.
I'm little slow in explaining things, right?
Okay, sir. Okay, sir. We'll proceed, sir.
Okay. See, we'll concentrate only on diesel vehicle, right? So, can I zoom it? So, these are all the technology which is, this is for BS4. BS4, the combustion, common rail direct injection is a CRDI. We have turbocharger, we have EGR. In the exhaust, we have a diesel oxidation catalyst. Diesel oxidation catalyst. These are all the technologies which are available in the BS4 vehicle itself. BS4 vehicle itself. Now, when you go to BS6, right, same CRDA is used, but with the changes in fuel injection system. What changes we'll discuss. Right, in the exhaust, it is only diesel oxidation catalyst. Now we are going to have a DPF, diesel particulate filter, then LNT, lean NOx trap for oxygen NOx controls, right? All these things are new things which are coming out. So please understand that. Before going to that, one more thing is also parallelly required. Parallelly required, which is when you implement the Euro 6 vehicles on the roads, right? You must get Euro 6 quality fuel. When you get a Euro 6 quality fuel, then only you can ensure that on the road you will get Euro 6 emissions, right? For that also, quality of the fuel should be enhanced, right? The quality of fuel in the BS4 and BS6, the major thing is sulfur content is reduced 5 times, 50 ppm to 10 ppm now. So please understand, slowly now we are getting Euro 6 or Bharat Stage 6 fuel. Okay, there are a lot of onboard diagnosis. Earlier we used to have very important things only. Now we have a lot of things, whether SCR is working properly or DPF is working properly. All those things we can have a OBD now. I already told you driving cycle, right? Driving cycle experiments will be conducted in lab or on road. Driving cycle emissions are tested in lab or roads. முன்னாடி சொன்னா இல்லையா, ரோட்ல டெஸ்ட் பண்ணுவாங்க சொன்னா, லேப்ல டெஸ்ட் பண்ணுவாங்க சொன்னா. This is how we are testing, right? Is it a road or lab?
Yes, sir.
Lab, sir.
Lab. Here the road is rolling.
Yes, sir.
The roller is rolling, right? Roller represents the road. Okay. Up to BS5 now, BS4, Euro 5, we have only laboratory testing. Now what is, can you read this? Real driving emission. Real driving emission. On the road we want to test now. That is the very, very toughest part for the emission vehicle manufacturers. SCR. Can you repeat SCR? Can anybody read? What is this? Selective
Reduction.
selective catalyst reduction. That is for NOx control. DPF.
Diesel particulate filter.
Yeah. LNT. What is LNT?
Lean NOx traps.
Yeah. All these technologies are
Learn
the
NOx
SCR and LNT for NOx, DPF for particulate matter. Is it clear? Right?
Yes, sir.
We'll
Yes,
see little glimpse of those things. OBD. In the OBD, you will find all the engines are now fitted with electronic control unit. Right? Electronic control unit will have all the inputs. Sensors will be given an input. Right? You will have a speed sensor, oxygen sensor. You will find temperature sensor. Several sensors are available. All these sensors will give an input. Based on the sensor input, right? ECU will actuate the actuators. Actuators mean the sense the fuel injector is actuator. Valves are actuators, right? Exhaust valve or you say EGR valve, right? So many places you will find actuators, right? So the sensors will give the signal. Based on the signal, ECU will operate, right? Now, during this operation, if there anything is fault, then MAL indication lamp, MIL, that will be there in the dashboard, right? If you are not able to correct, then you have to connect a scanning tool, right? External scanning tool. Each vehicle will have a separate port, right? With the separate port, you can able to insert it and you can able to see what is really happening, what is the problem, right? This is OBD2 technology. OBD1 is outdated now, OBD2. Now OBD3 is also, everybody is planning. See, now the important change is there will be a separate yard will be available, road will be placed, right? And your vehicle is not running on the dynamometer, chassis dynamometer. Now it is running on the road. All the measuring instruments will be fitted into the car. Real emissions continuously taken. Real emissions are continuously taken. That is the toughest part with respect to BS6 standards. Is that clear?
Yes, sir.
That is a
Yes,
big
sir.
change. In the first change, I told you BS6 fuel you require. Second change, I told you OBD2, 3 technologies. Third is RDE, real driving emissions. Then common rail. In the common rail, what are all the advances now we have? Just to have a glimpse, what is the pressure with which the fuel is injected? Just now we discussed. In diesel engine, what is the pressure with which the fuel is injected? Mechanical injection, I told you, no?
Sir, 200 to
200 to
1000 bar.
1000 bar. Very good. 200 to 1000 bar. Now, when I say electronic assisted mechanical injection, that is common rail diesel injection system, then automatically the fuel pressure rises up to 2500 bar. Right? Can you repeat? What is the pressure?
Sir,
2500 bar. In Indian roads, we already got 1600 bar, but the maximum pressure they went up to 2500 bar in CRDI. Now that we are increasing the pressure. What is the advantage of increasing the pressure? When I increase the pressure, then droplet size will be reduced. Right? I already told you air is heated by means of higher compression ratio. Right? So air is heated up to 700 degrees centigrade. Now we are injecting the fuel. When I inject the fuel, injection pressure decides the size of the droplet. When the droplet size increases or decreases, right? When the pressure increases, then droplet size will be decreasing. Almost in the atomized state, I am trying to inject the fuel, right? So heat transfer is directly proportional to the surface area. Heat transfer is directly proportional to the surface area. Now I am splitting the single droplet into multiple droplet. So surface area is enormously increased. So delay period is directly reduces. Is that clear? How I am going to inject? That is where the technology lies, right? Normally in the mechanical injection, I can start injection, duration with which the fuel injected, then it will be off, right? Lift, fuel injection will start, continuously flow, then it will close. That's all. But in diesel CRDI system, I can inject up to 9 injections. Up to 9 injections per cycle. Per cycle. This is called split injection. Can you repeat the term split injection?
Split injection, sir.
Yeah, there are 3 parts of the split injection. One is pre-injection, main injection, post-injection. Can you repeat?
Pre-injection, main injection, and post-injection.
Yeah, right. Every cycle can differ. Every cycle can differ depending upon the inputs what we receive. That can differ. Can we see the small video about CRDI?
Okay, sir.
Yes, sir.
This is a Bosch system. You look at the technology, you will appreciate the technology. So this is a CRDI engine. This is ECU.
Sir, the video is not visible, sir.
Video is not visible.
No, sir.
No, sir.
How? I don't know. Okay, let us not worry about it. What is this?
Sir, minimize your screen and play the video, sir.
Huh?
Sir, minimize your screen and play the video, sir.
Oh, minimizing the screen will allow the play video. I'm not very familiar with the technologies.
Are you
I'll
directly?
try again.
Okay.
Is it now visible?
No, sir. No, sir.
Okay, I will share all the videos. Right, later you can see.
Okay, sir.
Sir, try stop sharing your screen and again share the screen, sir.
Stop sharing.
Now you share the screen and then share the video, sir.
Where is that share screen? Okay, share.
Yes, sir.
The screen is visible?
Yes, visible, sir. Visible. So you can play the video, sir.
Now visible, sir.
Now is it visible?
Yes, sir. Yes, sir.
Okay, okay, good. It's a very short video. So look at it. This is a common rail. What is the pressure? What is the pressure?
200 to 1000.
2500 bar.
Okay, sir.
This is a high pressure pump.
Sir, is video playing, sir? Sorry for disturbance.
Yeah. This is common rail.
Video is not visible, sir. Video is not visible, sir.
Okay, let us not worry about it. Videos will be better in explaining, but if it is not coming, let us not
Play,
worry
sir.
about it.
Play option.
Let us not worry about it.
Okay.
Look at, see, we can able to imagine things. As engineers, we should be in a position to imagine, right? So now, look at what is the time available for the fuel injection. It will be around only 2 milliseconds. What is 2 to 5 milliseconds? What do you mean by that? Well, what is 1 millisecond?
So kindly share your presentation screen, sir. The screen on.
That is also not available now.
You can again share, sir.
Where to share? Share screen. Oh. Now can you see video?
Yes, sir. Yes, sir. Yes, sir. Visible, sir. You can just click play, sir. Click play. From start.
So this is the common rail engine. It's highly efficient. So fuel savings. Fuel savings will come with the CO2 emissions savings also.
So increased volume. Volume is there?
No volume is there.
Oh, okay, sir. Okay, sir.
Okay, this is a fuel injection pump. There will be a sensor. There is a high pressure pump which is operated at 2500 bar. This is the high pressure pump called a CR pump. This is the high pressure common rail, right? This common rail, major advantage of common rail is it is independent of engine speed. Independent of engine speed. Non-mechanical systems are dependent on engine speed. When engine speed is low, we cannot expect high injection pressures. But here, we can able to expect any injection pressure even at a low operating speeds. This is the injector. Piezo injectors. Piezo electric pressure transducers will be there. So it is operating for 2500 bar. Can you see the injection?
Yes, sir.
Yes, sir.
This itself a very nice thing. But what happens now? This is your ECU. Injector. Can you see now? Pre-injection, main injection, post-injection.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
Now, can you see parallelly? You should see this graph as well as this injection. Then only you will understand what is this. Are you able to see?
Yes, sir. Yes, sir.
See, within one cycle, I am going to inject 1, 2, 3, 4, 5, 6, 7. 7 times I have injected. Right? 9 times it is possible. Right? That means within normally 1 millisecond means 1 by thousandths of a second. 1 by thousandths of a second is 1 millisecond. Right? So here, everything happens within 2-3 milliseconds. So look at the genius nature in which precision with which the Bosch is manufacturing CRDA systems are working. So please understand and appreciate. We can talk 1 hour about the CRDA itself, right? So with this thought process, I just open out the process so that you can able to go further into it. Now again, I have to share this.
Screen is visible, sir.
It is visible?
Yes, sir. Yes, sir.
Okay. Now, so this CRDA system will reduce NOx emission, CO emission, soot emission, everything can be reduced, right? want to go. Right, now next is exhaust gas recirculation. The exhaust gas recirculation means what? Part of the exhaust, from the part of the exhaust through a control valve, right? It goes into the intake manifold. What is the use? When the exhaust, see, 10% of the exhaust, say for example, it is circulated into the intake manifold. What is the advantage? Already burned charge is now going into the intake manifold along with the fresh air. What is the advantage? See, why the NOx is formed? I told you 3 things. At least 2 things you should be in a position to remember. What are those? When the NOx will be formed? When the NOx will be formed? High temperature and availability of oxygen. Is I am right? High temperature and
Yes, sir.
availability of oxygen. Both things, high temperature as well as availability of oxygen, will be disturbed when you go for EGR. How? When you circulate EGR, that means what? 10% of the exhaust is going into the intake manifold. That means what? Only it is allowing 90% of the fresh charge, 10% of the burn charge. Is that right?
Yes, sir.
So, while the combustion takes place, what happens? It will interfere with the combustion process, right? The already burned charge will not burn again, right? So, it will contain what? If it is a combustion gases, major portion of the exhaust gas is what?
NOx.
NOx, not NOx, CO2 and H2O.
Okay.
Carbon dioxide and water vapor. These 2 gases will have a higher heat capacity in nature. Higher heat capacity in nature. So, high temperature, high heat is produced. That heat is part of the heat will be stored in the CO2 and H2O. So, the peak combustion temperature will reduce. When the peak combustion temperature reduces by 10%, NOx reduces by 40%. Right? If you are able to reduce 10% by 10% of peak combustion temperature, then NOx can be reduced by 40%. So temperature is reduced. Then second thing is oxygen availability. If 100% oxygen is going, right now it is only 90% oxygen is going. So oxygen availability is also disturbed. So both the cases, NOx will be reduced. Is that clear? Is that clear? EGR.
Yes, sir.
Now EGR is already available. What really now they are doing is, so when what is the temperature in the exhaust? It will be around 300, 500, 600 degrees centigrade, depending upon the engine. When I 600 degrees centigrade directly going into the intake manifold, what will happen? 10%. Then what will happen? It will heat the incoming charge also. So volumetric efficiency will be reduced drastically. So now what they are doing is, they are cooling the EGR, the cooled EGR. When directly it goes, it is called hot EGR. When it is cooled by means of a heat exchanger, then it is called cooled EGR. Now the people are working closely with the cool EGR. Right? Cool EGR further reduces soot emission. Is it clear? Difference between hot EGR and cool EGR. Is it clear?
Yes, sir.
Right. Now, there's one more concept which is emerging is HCCI combustion, homogeneous charge compression ignition engine. Right? See, earlier I told you what is the latest technology for SA engine. Latest technology, GDI. What is GDI? Gasoline direct injection engines. Now it is HCCI. Earlier it is only a heterogeneous system. Now it becomes homogeneous. Right? Just like a petrol engine, I am going to prepare a homogeneous air fuel mixture. I am going to compress it. So please understand. Here only air. This is a diesel engine. What happens? The diesel engine, air is injected inside the engine during the intake stroke, and it is compressed. Air is compressed well above the self-ignition temperature, and the fuel is sprayed. Here in petrol engine, homogeneous charge is prepared and is compressed to a little value. Then spark plug will initiate the combustion. Here I am going to combine these two. I am going to prepare a homogeneous air fuel mixture, and I am going to compress it to a well above the self-ignition temperature, and combustion will initiate at the instantly. Right? That is a homogeneous ignition engine. What is the advantage? Advantage is huge. Right? This blue color. Can you see the blue color?
Yes, sir.
It is well away from what? Core soot emission and core NOx emission. Right? You will
Yes,
have a
sir.
soot when you operate at 1800 degrees centigrade with a equivalence ratio of 5, then you will have a very, very high soot emission. NOx emission will be very low. When you operate at 2600 degrees centigrade and with even one equivalence ratio, then you will find NOx emission will be more. But when you operate at a low temperature combustion mode, right, HCCA engine, your NOx is also reduced greatly and soot is also reduced greatly. Right, this is one of the promising technology for achieving Euro 6 norms. Only problem with HCCA engine is when you operate at full load. When you operate at full load, right, your NOx is peaking. Right, NOx will be very high. Right, if you look at it, this blue line extending up to this, like a spark ignition, it will have a high NOx. Okay. But up to 75% load, we can operate at a HCCA engine with a very, very efficiently, and we can able to reduce the emissions by very, very low value, both the NOx as well as soot. Is it clear?
Yes, sir. Yes.
Yes, sir.
Okay. Now we'll go for after treatment device. Right. Before going to that, I'll again play a small video so that 2-3 minutes video you will understand what it is. Okay. I think now you can able to see video.
2014, all newly registered vehicles must meet the requirements.
Are able to see?
Yes, sir. Yes, sir. Yes, sir.
In comparison with Euro 5, Euro 6 sees a reduction in NOx emissions by 80%. The reduction in the
Slightly increase the volume, sir.
56%.
If
You
possible.
want to increase the volume?
Yes, sir. Yes, sir.
Emission control technologies.
Okay, sir. Okay, sir.
Pure diesel, EGR, and MAN AdBlue, SCR, are technologically combined for the environment-friendly Euro 6 diesel engines. A new feature of the MAN Lion City is the use of the additional operating fluid AdBlue for nitrogen oxide.
Please understand what is this? Can anyone read?
AdBlue tank, sir.
AdBlue tank.
AdBlue tank. It is nothing but urea. Right?
Okay, sir.
It is an exhaust, diesel exhaust fluid, DEF. Just like your diesel lubricating oil, you will have one more tank, right? That is AdBlue tank for SCR technology, right? You have to fill that also. Is that clear?
Sizes for the non-toxic and non-hazardous urea solution are matched to the diesel tank volume. The fully developed MAN engine technology with common rail fuel injection, regulated exhaust gas recirculation, EGR, and two-stage turbocharging.
Now, what is this turbocharger? Turbocharger in 2 stages, right? What is the advantage of 2-stage turbocharging? A lot of advantages are there in two-stage turbocharging, right? So when you are having a fixed turbochargers, we'll have performance issues, right? Turbo is a rotary machine and which will operate efficiently only for a particular band width, right? If it is the bandwidth is increasing or lower value to the higher value, then your system will not be efficient, right? So low pressure turbine, high pressure turbine, both, see, normally low pressure turbine will be in operation. Whenever the speed is high, then high pressure is also come into existence, right? So at all operating points, turbocharger will be efficiently giving air, right? That is the idea. Is it clear? There is no turbo lag.
Will be supplemented by the new SCRT system.
So what is this? SCRT. SCRT is equal to
CRT plus SCR.
CRT plus SCR. What is SCR? I just now told you.
Selective catalyst reduction.
Selective catalyst reduction. CRT. Continuously regenerating trap. DPF.
The SCRT system is located in the two-stage exhaust silencer. It consists of the particulate filter, which has been enlarged in comparison with EEV, and the downstream SCR catalytic converters. The particulate filter features an electronic monitoring function that indicates when cleaning is necessary. The particulate filter achieves a separation rate of up to 99%.
So what is this particulate filter? I told you, no, the soot particle, right? I told the soot particle, right? In
Yes,
diesel
sir.
engine emission, the soot particles will be trapped inside, right? Just like a coffee cup. Coffee cup, how much coffee you can pour? Can you so you're having a coffee cup in your hand, right? A jug of coffee. How much you can pour? How much you can pour? Is my question is clear? We have a large quantity of coffee. I am having a small cup in my hand. How much coffee I can pour into the cup? It is up to the cup capacity, right?
Yes, yes.
If it is beyond that, what will happen? It will spill. Is I right?
Yes, sir. Yes.
Right. The same way, this is also a filter, right? A lot of soot particle will enter into it, right? Will enter into it, and it is having some capacity, saturation capacity, right? Up to that capacity, it will trap all the air fuel, so that is soot particle. Remaining things will be sent out, right? While, see, there is a pressure sensor here. See, there is a tap here, right? There is a pressure sensor. Another one is a pressure sensor, right? Inlet and outlet continuously. ECU will monitor the pressure difference. Inlet and outlet of the particulate filter, right? End up now, when it is saturated, when it is full, then what will happen? We have to regenerate the surface. We have to burn out all the carbon, right? Once you burn out all the carbon, then again the fresh surface will be there. It can again will be ready for the next cycle of operation. Is it clear?
Yes, sir.
They be generated by oxidation of the soot particulates retained in the filter material into gaseous carbon dioxide. The particulate filter is therefore largely maintenance-free. Demand-based injection.
Now AdBlue is coming out, right? What is AdBlue? What is the fluid that what it contains?
Urea.
Urea. right? Why urea is required? We need ammonia. Ammonia is a poisonous gas. Poisonous gas, right? We want to store it as ammonia, but urea is the little easier for us to carry, because even for agriculture we use urea, right? Human urine is also urea only, right? That is not a dangerous thing, but ammonia, that we need only ammonia, right? Please understand, we need only ammonia, but we use a AdBlue fluid which contains urea, right? Please look at it. After, see, yellow color is oxidation catalyst, then it goes to diesel particulate filter, then the exhaust gas will enter into the green color, that is SCR catalyst. SCR catalyst. Before entering to the SCR catalyst, this gas will mix with the AdBlue fluid.
The solution takes place after the particulate filter. Ammonia is produced from the urea in the SCR catalytic converter module, enabling subsequent chemical conversion of the nitrogen oxides into the harmless substances nitrogen and oxygen.
Are you able to understand?
Yes, yes.
Catalytic converter prevents it.
See, this is cleanup. Sometimes what happens is, if you supply a little excess ammonia, then this ammonia will not be consumed by the NOx, right? Less NOx is available, more ammonia is there. This is what we call as ammonia slip. Ammonia slip. This slip should not happen, right? If at all it happens, then this orange color converter will convert that also.
Ammonia, so-called ammonia slip. MAA.
So I will repeat this particular portion so that you will be in a position to better understand. It is only 1 minute. I will not disturb you.
It consists of the particulate filter, which has been enlarged in comparison with EEV, and the downstream SCR catalytic converters. The particulate filter features an electronic monitoring function that indicates when cleaning is necessary. The particulate filter achieves a separation rate of up to 99%. The system is continuously regenerated by oxidation of the soot particulates retained in the filter material into gaseous carbon dioxide. The particulate filter is therefore largely maintenance-free. Demand-based injection of the AdBlue urea solution takes place after the particulate filter. Ammonia is produced from the urea in the SCR catalytic converter module, enabling subsequent chemical conversion of the nitrogen oxides into the harmless substances nitrogen and oxygen. The ammonia oxidation catalytic converter prevents emission of excess ammonia, so-called ammonia slip. MAN is...
Is that clear?
Yes, sir. Yes, sir.
Now you look at it, this is DOC, diesel oxidation converter, then DPF, then DEF. I have already told you what is DEF. This is exhaust fluid. That is your AdBlue. Catalyst, again final catalyst, then it goes to the exhaust. So this is what happens in the SCR, right? The waste gas and urea will go together, right? It will form NO plus NH3, ammonia, in the presence of oxygen. It will be converted to N2 and water vapor. Then diesel particulate filter, right? There's a special material which will be available at high temperature also. It will withstand. Ceramic substrate will be there, and the passage will be like this. When it goes inside, then through porous medium, right, these gases will go, right? Only the particulate, soot particulate, solid particles will be trapped here, right? When the surface is full, then the back pressure will be increased. When the back pressure will be, so you find this, there is a one trap here, the one more trap here. The difference in pressure is always maintained, right? When it is exceeding a particular value, that means what? The particulate trap or particulate filter is full. So you need to regenerate. There are several ways of regeneration. One is we can inject more fuel. We can operate in the rich mode, right? So that it will burn out all the things, or electrically you can heat it. There are several such technologies are available. Once it is regenerated, then automatically you will find the next cycle it will be ready. Diesel oxidation catalytic converter. It is used for conversion of CO and HC to CO2 and H2O. Now it is also used for NO to convert into NO2 also. Lean NOx trap. This is again one more video. Lean NOx trap.
Continuously only NOx by quickly a three-way catalytic converter. But it
So that screen is not visible, sir. Video screen.
Immediately a three-way catalytic converter. But it works in
Sir, screen is not visible.
It's visible. Okay, sir. Now it's visible.
Yes, sir. Now visible, sir.
The result of lean NOx trap is very much similar to a three-way catalytic converter.
So slightly increase volume, sir.
Okay.
Okay.
Now, please look at it. This is also like a catalytic converter. Lean NOx trap. Just like particulate filter. Particulate filter traps what? Particulate filter traps what? Particulate matter, right? So same way lean NOx trap. The name itself says what? It will trap LNT. Lean NOx trap means what? It will trap the NOx, oxides of nitrogen. Okay.
A very much different way. Lean NOx trap removes NOx in the exhaust. The formed NOx is stored on the catalyst coated with metals of platinum, palladium, and barium. It's
Platinum and palladium for oxidation, barium also for storage.
direct reducing. Here we are storing the NOx in a metal. So the working have two stages. The first stage is done when the engine is running with a lean mixture, and it will proceed to the second stage when the engine turns to a rich mixture zone, where the fuel content is higher than stoichiometric mixture. So let's look at how the conversion process happens in an LNG device. These are the reactions that is taking place in lean NOx trap device. First, the NOx will be converted to nitrogen dioxide. Then the nitrogen dioxide.
See, all the NOx will be converted into NO2. That means what? NO2, NO2. Only in the engines we deal about NO and NO2. Already NO2, we don't bother about it, but NO to be converted into NO2. Right? That is the first step. That is why we have a diesel oxidation catalyst, which will cater this oxidation also.
It will react with barium carbonate to form barium nitrate and carbon dioxide. Then it will react with carbon monoxide and hydrocarbon to produce carbon dioxide, free nitrogen, and barium carbonate, just like the initial state. The first two reaction happens in a lean mixture form, and the last reaction happens in a rich mixture form. I will explain in detail how it works. So
listen, what is the platinum role? What is the platinum? I told you. Platinum is the oxidation catalyst. Platinum is the oxidation. Platinum, palladium for oxidation. Rhodium is for reduction. Right? The platinum will convert all the NO to NO2. Okay.
Reaction comments with the lean atmosphere. In the exhaust, we have nitrogen monoxide and free oxygen because we are running in a lean mixture which contains excess air for producing free oxygen as well as oxides of nitrogen. So it will enter into the metal. First job is for the oxidation catalyst platinum. Its job is to convert the nitrogen monoxide into nitrogen dioxide as shown. So the platinum will help to convert all the nitrogen monoxide in the exhaust to nitrogen dioxide. So then the absorption process will start. There is three.
See, once NO2 is formed, this NO2 will react with the barium nitrate, right? We have already known, right? NO2 and barium carbonate, right? These two will mix. There's a metallic compound. This metallic compound will form a barium nitrate plus CO2. CO2 is a gas, so it will leave, and NOx will be stored in the form of barium nitrate. Is that clear?
Then its job is to convert the nitrogen monoxide into nitrogen dioxide. So then the absorption process will start. There is 3 oxide in barium carbonate. So the barium carbonate will react with the oxides of nitrogen to start the absorption process. So the barium carbonate will absorb the NOx and it will emit carbon dioxide, and there will be free oxygen if there is enough of oxygen there. Absorption process.
So barium carbonate, now it is converted to barium nitrate. You clear? NOx is absorbed. There is a capacity for this substrate also. It is not possible to keep on storing, just like a coffee cup. Coffee cup can handle only a small quantity of coffee. Same way, this absorption capacity of this barium carbonate is also limited. So again, we need to regenerate the surface once it is reaching the saturation limit.
We get complete when all the barium carbonate get converted into barium nitrate. So the process will be complete. So now it is impossible to absorb any more NOx that is produced during the combustion process. So it will lead to higher emissions. For preventing this from happening, we have to convert the barium nitrate into its initial stage, which is barium carbonate stage, to absorb the NOx. For this, we have to switch the engine to rich mixture stage for converting the barium nitrate to barium carbonate.
So we have to switch over to the rich state, right? So we need a carbon for that.
And then excess fuel, which means the exhaust will have hydrocarbon, which is the unburned fuel, and there will be also carbon monoxide. Now the barium nitrate will react with the hydrocarbon and carbon monoxide to become barium carbonate, just like the initial state.
So now, when you operate at a rich operating conditions, you will have hydrocarbon, carbon monoxide, right? This hydrocarbon, carbon monoxide will react with the barium nitrate. It will form a barium carbonate, right? Just like a previous reaction. Barium nitrate plus CO and HC will form a CO2, N2 and barium carbonate, right? In the process, totally NO2 will be removed. Initially, all the NO2 will be converted and stored in the form of barium nitrate. Once the storage capacity is over, then rich mixture will be supplied to the engine for a short duration, where the regeneration will be started. It will become N2, and again all the surface will become a barium carbonate. Now the surface is ready for absorption of the next cycle. Is that clear?
Yes, sir. Yes, sir.
Okay, my presentation is over. I have concentrated only on CA engine. In SA engine, we have a lot of technologies which are available to go for Euro 6 norms.
So thank you, sir. It's a very nice presentation, sir, for explaining all the terminologies in the technologies related to BS6 norms. And your explaining in the videos will be very, very attractive, sir. So thank you, sir. So Akshay.
Thank you.
Okay, sir.
Any questions are there?
Sir, if dear participants, if you have any questions, means kindly ask.
I already taken a lot of time, so students may not ask questions, I think.
Sir, I have one doubt, sir.
Yeah, please.
Thank you, Bhaskar. Lakshmi.
Sir, Lakshmi sir, how are you?
Good evening. Very good. It was an interactive session, complete interaction. You are almost with the discussion with the students.
Yeah,
I joined
always,
from 3 o'clock. I had a class from 2 o'clock. Yeah, I joined from 3 o'clock till now.
Thank you, sir.
So I have one small doubt, sir.
Students are very nice. They are interactive.
Sir, is there any change in material related to engine in a BS6? Hello?
I'm not getting it, sir.
Sir, in BS6 engine, is there any change of material, sir, in already existing for BS4 to BS6?
No, you want to say material means engine component?
Engine component, sir, engine component.
Yeah, engine component, normally the worst component will be affected is the piston surface, top surface, land, we say piston land and first ring. These two are subject to higher temperature. Now, there's one more thing in petrol engine, we are reducing the temperature. How we are reducing is we use a big engine, but downsizing it. It can produce 100 kilowatt, but I'll operate only for 75 kilowatt.
Okay, please.
Right. So, in those cases, you will not find any problem. But diesel engines, they are optimized the engine, so temperature will rise.
Then only the maximum company will produce only petrol engine in BS6.
Yeah, BS6. Yes. BS6 will be little easier.
Yes, sir. Yes, sir.
See, you can go for higher. See, what the people are trying is they can reduce the compression ratio and they can go for turbocharging. So, reduction in compression ratio will reduce the volumetric.
Okay, sir.
Okay, that is another thing.
Okay, sir. Okay, sir. Thank you, sir. Hey, any other questions from student side?
I think I have shooted up time.
Okay, sir. Akshay?
Okay, sir.
Next.
Thank you, sir, for taking your time out and being here for us today. Thank you for spending your valuable time and sharing your valuable knowledge to us, sir. Now, I would like to invite and request Professor J. Senthil, sir, Associate Professor of Department of Mechanical Engineering, AVIT, to deliver the vote of thanks on this occasion. Please, sir.
Thank you, Akshay. Good evening to one and all who have joined behind the screen and in front of laptop screens. So it's so pleasure in giving a wonderful session by Dr. K. Bhaskar, sir. Thanks a lot, sir, for joining us in today's evening and sharing your expertise. As rightly said in the starting by Dr. Prabhakar, you are a man of this topic. It was very well versed while your deliberations. So let me go for the very formal vote of thanks. On behalf of the Department of Mechanical Engineering and SAE College Club of AVIT, let me thank our magnanimous management for giving us all the support financially and morally for this wonderful webinar. I thank the resource person, Dr. K. Bhaskar, Professor and Head Department of Mechanical Engineering, Rajalakshmi Engineering College, for accepting our invitation. And it was a very wonderful interactive session. In the quite sometimes the Department of Mechanical Engineering and the institutes and the Arbitrated Institute of Technology is locked with the lot of programs. I could say in the lockdown, we have been locked with the lot of seminars on par with the webinars for betterment of the students community. And this would be one of the top-notch program because it was more vibrant and interactive with a lot more examples and videos. The students also cleared almost their doubts in this emerging topic. So on bottom of the heart, we sincerely thank Dr. K. Bhaskar for sharing his expertise and among the students community. Thanks for your participation, sir. We sincerely thank our principal, Dr. K.L. Shanmuganathan, who has been a constant support for organizing any kind of a program and giving us a complete freedom to organize such events. Thanks to our vice principals, and special mention thanks to our head of the department and also the vice principal admin, Professor L. Prabhu, who has been a motivating factor for all faculty members to organize such kind of programs and also for his bountiful guidance. A special thanks to Professor Dr. M. Prabhakar, who has delivered a welcome address and also been a motivating source of inspiration for the department in organizing such kind of programs. Thanks to Professor Lakshmi Narayanan, who has been helping to Tyagarajan in identifying the resource person and also a good old friend of the resource person. Thanks, Lakshmi Narayanan sir, for your support forever. A special thanks to the coordinator of the program, Professor Tyagarajan, and all the faculty members, the moderator of the day, final year student Akshay, and Sam for hosting this program through the Zoom platform. All the faculty members and all my dear students who has been patiently waiting for almost 2 hours, I suppose, for this wonderful webinar. Thanks a lot for wonderful participation. Your feedback link has been posted in the chat box. Kindly fill it up for your participation certificate. We will meet once again in another program for the, like this, and another eminent speaker may join for another emerging topic. So once again, I thank the resource person, Dr. K. Bhaskar, and all the participants, faculty members for wonderful participation. Thanks a lot for your participation. Thank you. Miles to go before we sleep. Miles to go before we sleep. Thank you.
Thank you, sir.
Thank you, sir. Can I leave, sir?
Yes, sir. Thank you, sir. Thank you, sir. Jagarajan, sir, I suppose I can leave. Thanks for your participation, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Feedback link will be posted on the chat box. Students kindly fill
Already put it, sir.
Yes. Sindhu sir,
Thank you for your participation. You can leave, thank you.
Thank you.
Akshay, it was a wonderful job, my dear Akshay.
Okay, sir. Thank you, sir. Thank you, sir.
Thank you.
Thank you, Akshay.
Sir, thank you, sir. Okay, sir.
Akshay, you can leave. Sindhu sir,
Okay, sir. Okay, sir.
wait for another 5 minutes for students